I will do about 3 or 4 examples of dividing polynomials. So the first example, we're going to divide a polynomial, a trinomial, by a monomial. So we're going to take 8x cubed plus 4x squared minus 12x and divide that by 2x squared. So each term in the trinomial needs to be divided by the 2x squared. So we could rewrite it like this: 8x cubed divided by 2x squared plus 4x squared divided by 2x squared minus 12x divided by 2x squared. And then just simplify each of these terms that you see. So we know that 2 goes into itself once and into 8 4 times. And when you are dealing with the exponents and the base is the same, so x cubed divided by x squared would be the same as x3 minus 2. So there's one x left over because both of these would cancel out and there'd be one left. So the first term would be 4x. In the second term, the 2 goes into itself once and into 4 2 times, and then x squared over x cancels completely, so we're left with a 2. And in the last term, 2 goes into itself once and into 12 6 times, and then 1 minus 2 leaves 1x in the denominator. So we have minus 6 over x. In example 2, and before we do example 2, we're going to review the basic algorithm for division. So if we take something like 737 and divide by 21. So if you recall, taking 21 into 73 goes in about 3 times, and then you multiply 3 times 1 and 3 times 2. You get 63, and you will subtract that. So we get 10, but 21 can't go into 10, so we bring down the 7. So now we take 21 into 107, and it goes in about 5 times. And again, repeat the process. 5 times 1 and 5 times 2, and then we subtract. At this point, we can say we have a remainder, and we write that remainder as a fraction over the divisor, so 2 over 21. So we have a mixed number, 35 and 2 over 21. Okay, so we're going to use that process to kind of help us, because now we're going to be dividing a trinomial or polynomial by a binomial. So in this example, we're going to take 2x squared plus 3y minus 40, and we are going to divide by y plus 5. So we'll write it with the divisor on the outside, y plus 5. Go ahead and use that algorithm. So we'll put the 2y squared plus 3y minus 40. And now we have to kind of work with this. This is an expression, y plus 5. So let's just work with the y. How many times does y go into 2y squared? So it's kind of like dividing like off to the side if you're having trouble visualizing that. If you want to take, just like we did in the last example, and divide by y. All right? So it's like a coefficient of 1. 1 goes into 2 2 times. Y goes into y squared, or we're canceling out a y, right? So what we have left over is 2y. Okay? So we're canceling out 1y from the top expression is basically what we're doing. So we'll put that over here above the 3y. So we'll line it up above the term that would be considered a like term, right? Because the exponent doesn't, the y doesn't have an exponent of 2, so we're going to put it over the like term. Now we're going to take that 2y times each of the terms in our binomial here. So when we take 2y times 5, Okay, 2y times 5, we get 10y. And we take 2y times y, we get 2y squared. Okay, so that was a positive 10. We need to subtract this whole thing, just like we did in our original algorithm. Okay, so let me get rid of this. When I do this, I want you to remember that when you're subtracting this term, it's like subtracting the 2y and subtracting the 10. Each term is subtracted from the original term. Okay, so we'll draw the line. So now we'll have 2y squared minus 2y, which is 0, that just goes away. A 3 plus a negative 10, or minus 10, is a negative, now, of course, look what I forgot. I always catch these things. Okay, so 3y minus 10y is a negative 7y, and then we'll bring down the minus 40. All right, now we're still going to do the same thing, repeat the process, y into a negative 7y. So we have this negative 7y, and we're dividing it by y, basically, so the y's will cancel. So up here we would have the minus 7. Then minus 7, negative 7 times 5 is a negative 35. Negative 7 times y is negative 7y. But remember, we're going to subtract the whole thing. So that kind of changes the signs, right? If you have subtracting this or taking the opposite of these, it makes this a positive and this a positive. So that when we simplify them, negative 40 plus 35 is going to be negative 5, and a negative 7y plus 7y cancels that term. So now this becomes our remainder. So we will write that as a remainder over the divisor. So minus 5 over y plus 5. So the solution, or the quotient, is 2y minus 7 minus 5 over y plus 5. Let's try another example. Now, before we do this next example, one thing that you have to remember is that if you're given a trinomial and you write it in standard form, you want, and there's a missing term or a missing power, you need to add a term of that power with a 0 coefficient. So we are going to take, in example 3, 4b cubed plus 5b minus 3. And this is going to be like a placeholder for the like terms, so to speak. So 2b minus 1. So in standard form, we have, descending order of the variable, and we have b cubed, and it goes right to b. So we want to rewrite this to be 4b cubed plus the 0 coefficient b squared, then the 5b minus 3. So that's what we're actually going to be dividing here. So our divisor, 2b minus 1, and then put the whole dividend with the placeholder. All right, and again, we're working with the first term. How many times does 2b go into 4b cubed? So again, it's like simplifying this expression, okay? So the 2's cancel, and 3 minus 1 is 2, so we would have 2b squared, and we'll put that over the one that has b squared. So 2b squared is the first term. 2b squared times the negative 1 would be 2b squared, and I'll put it under the like term, okay? 2b squared times 2b is going to be 4b cubed. And remember, I'm subtracting that, so that makes a negative 4b and a positive 2b squared. So when I add them, a 0 plus 2, so this will be 2b squared. 4b cubed minus 4b cubed, make sure that it does cancel. Now I want to bring down the entire rest of my polynomial, so plus 5b minus 3. Take the 2b into the 2b squared. Okay, so this is what we're doing. We're simplifying this expression right now in this second step right here. So the 2's cancel, and 1b up here would cancel with this b. So I would be putting 1b above the 5b. So then I'll multiply. B times the negative 1 becomes negative b. B times the 2b becomes a positive 2b squared. But remember, I'm subtracting this whole thing, so that changes this sign and it changes this sign. And then 2b squared minus 2b squared cancels out. 5b plus b is equal to 6b. Bring down the negative 3. Repeat the process. Working with the first term of the binomial. 2b goes into 6b. This is what I'm simplifying. I need to write this off to the side. B will cancel. 3. So I would have plus 3. And then I multiply. 3 times a negative 1 is a negative 3. 3 times 2b is a positive 6b. But I am subtracting the whole thing. So this becomes negative, this becomes positive, and then 6b minus 6b cancels, and negative 3 plus 3 cancels, and I have a remainder of 0. So my quotient for this problem is going to be 2b squared plus b plus 3. And you can always check your work, because if I took my quotient and I multiplied it to my divisor, the 2b minus 1, I should get the original dividend. And you would find that the coefficient of 0, b squared, would be absent, so it would simplify to this original problem that we started with. And finally, one more example. Example 4. Negative 3x plus 4 plus 9x squared divided by 1 plus 3x. All right, so if you can look at this the way it's written, you can see that it's not written in standard form or descending order of the variables. We want to rearrange both dividend and divisor. So we will rearrange terms, and then there won't be any need, so we would have a positive 9x squared minus 3x and a positive 4. And that will be divided by, rearrange these terms, positive 3x and a positive 1. So put the divisor outside and your dividend underneath. And we're going to work with the first term. 3x goes into 9x squared. So this is what we're simplifying. Okay, 3 goes into itself once and into 9 3 times. 1x will cancel with this x. So we would have 3x and put it above the like term, and it's positive. 3x times 1 is a positive 3x. 3x times 3x is a positive 9x squared. Subtract the expression, which makes this negative and this negative. So 9x squared minus 9x squared cancels. A negative 3x minus 3x is negative 6x. Bring down the rest plus 4. 3x goes into a negative 6x. So negative 6x divided by 3x. The x's cancel, and this becomes a negative 2. So I would put my negative 2 above the 4. Negative 2 times 1 is going to be negative 2. Negative 2 times 3x is going to be a negative 6x. But I am subtracting the entire thing. Makes this positive and this positive. So negative 6x plus 6x is 0. 4 plus 2 is 6. And that is my remainder, so I will write it as plus 6 over 3x plus 1. So my quotient in this problem is 3x minus 2 plus 6 over 3x plus 1. And again, if I wanted to multiply that times the divisor, I could check it and get the original answer.